At the very beginning of Python 3, there was a project called Python 3000. It was in 2006. It started with a PEP, the PEP 3000 called Python 3000. And the idea was to focus on what is called Python warts, because Python 2 got more and more users, and slowly people started to complain about some design issues, and this design issues started to be collected as a list, and they were called the Python warts. For example, in Python 2, you have two different types for integers. You have the long integer and the small integer. And depending on the value of the number, depending on the operation, you may get a small or large integer. And in that case, to test the type of a variable, you have to test for both types at the same time. And this can be surprising for newcomers. They may not understand why we have two different things for the same kind of value, a number. There is also something called new class. It's a new addition during the Python 2 development. The new class should be used to get new features like, for example, Python properties. If you don't use a new class, the properties don't work as expected. And again, it's a little bit surprising that you have to inherit explicitly from the object type to get the new class. And it's surprising for newcomers. For the division of two integers in Python 2, you get an integer. This was a choice made from the beginning of Python. But when Python became more and more popular, some people were surprised by that they didn't get a float, because in other languages, on using a simple calculator, you get a float. So it has been decided to change that to always return a float, because there is already an operator in Python 2. It's instead of a single slash, you put a double slash, and you always get an integer. For the Unicode, in short, I would say that if you only use bytes, you're fine. If all your inputs, all your outputs, all data inside your application are bytes, there is no issue. But if you use Unicode as inputs, outputs, Unicode everywhere in your application, you are also fine. But you start to get some nasty issues when you have bytes and Unicode in your same application. Especially, you don't get errors all the time, but only if a single character has an accent. So it's a little bit difficult to debug such issue. It may happen in production, and more and more people were angry against this design. For the comparison, Python 2 again made a choice from the beginning, is that you are always able to compare two variables in Python 2. It means that if some object doesn't make any sense for comparison, Python takes the name of the type and compares the name. For example, if you compare the string hello and the number 3, you get the string str for the type string, and you get the string int for the number 3, and you compare these two values to decide how to order values. And this behavior can be surprising and maybe not the one that you may expect. So we also decided to change that and not try to guess, but to raise a type error in Python 3. It means that in Python 3, you have to make it very explicit. And finally, for the import, another trap for newcomers is that if you have a module which has the same name than a module of the standard library, like the sys module, you get a conflict between the module from the standard library and in your project, because Python decided to use something called relative imports, which means that you can import a module in the same directory without having to specify the full path to the module. So again, we wanted to change that to always use absolute imports, which means that you always have to write the full path to the module to avoid such name conflict. So to make sure that Python 3 is not going to be a big mistake, from the very beginning of the project, we tried to have something called risk management to not break everything. And the idea is that to only change acknowledged words, so only the very short list of design issues. And we also decided to have an open community process to decide what should be changed. And the process where the PEP with a number starting with 3,000. And we also decided to not re-implement Python from scratch, the CPython, the implementation of the language. It's not done from scratch, but it's just a fork from Python 2. Again, it's to limit the number of subtle changes that you may get if you do it from scratch. And again, from the very beginning, we decided to put a deadline for Python 2. At the beginning, it was 2015, I think, to say that today you are fine with Python 2, but be prepared that at this time you will have to switch. And in 2008, the Holy Grail, Python 2, the first release.
Can you do it again?
The Holy Grail. And it was 10 years ago. And the first migration plan was very, very simple. You take your whole application, all dependencies, everything. You run an application called 2 to 3 to convert your Python 2 code base to Python 3 and done. Okay, maybe it was not that easy in practice. Maybe there are some practical issues. Because the thing is that when you have a third-party dependency, the author of the module maybe don't want to drop all the Python 2 user base, because when you run 2 to 3, you lose Python 2 support. And when Python 3 has been released, Python 3 was a new thing. It was not supported by a Linux distribution, for example. It was not installed by most users. It was really something very new. So many users did not want to hear anything about Python 3. And another practical issue is that even if you succeed to port a dependency to Python 3, it's not enough. You really have to port all your dependencies on dependency of dependency of dependency of. And so you cannot start to port your own application before you port dependencies. So it takes a lot of time just to start on your own code. And another bad or good surprise is that we didn't know that Python 2 was so much popular, and it was heavily used in production. To explain you another problem called technical debt, imagine that you are talking with your manager, and your manager asks, "Why should I let you work on Python 3 support?" And the developer say, "For all these new cool Python 3 features." And manager, "Okay, but can I use all these features?" "Well, we still have to support Python 2. Nope. Because when you support Python 2 and Python 3 in the same code base, technically you cannot use Python 3 features because you have to support Python 2. So you can spend a lot of time to port everything, but at the end you don't get any kind of direct benefit from the ports. So you have to spend a lot of time for no gain, and it's difficult to justify if you have a manager on top of you. If you would like to port an application to Python 3, you have different options for the code base. For example, you can decide to have 2 different branches in Git. And one example is that the DNS-Python project has been forked. There were 2 different projects, DNS-Python for Python 2 and DNS-Python 3 for Python 3. Sometimes the maintainer of the project doesn't care about Python 3 because, for example, of the hairy manager. And so the community decided to fork the project. For example, the Peel module has been forked as Pillow. It's a module to manipulate pictures, to resize and do whatever you want with pictures. And not only they added Python 3 support, but they also added new features, which is really cool. And in the worst case, you are stuck by a dependency like MySQL Python. I was working on OpenStack, and all OpenStack rely on this module. But the maintainer decided to not reply to any bug reports. He didn't reply to pull requests. So we were stuck and we didn't know what to do. So someone decided to maybe just fork the project and then put it as a new name. But then you get a new issue is that for Linux vendors like Red Hat, we didn't know if we should rely on the old version or the new version, because we don't know if the old version is going to die or maybe it's going to be maintained for the maintainer decided to wake up. And to give you an idea of what was Python 2 at this time, you have to know that when Python 3 has been released, the stable version of Python 2 was 2.6. And the issue with Python 2.6 is that you have to make a lot of changes to make your code compatible with Python 3. For example, for all Unicode string, we add the U prefix to annotate the Unicode string. But if you do that, you get a syntax error in Python 3. So to be able to have a single code base for Unicode string, you have to remove the prefix and call a function from the 6 module. So you have to write 6.u parentheses your string. It was a little bit annoying to do that on all your string, and because of that, some project just decided to not do anything for Python 3. And another issue is that if you really want to use new Python 3 features, like the new method of the unit test module, you can use something called unit backports, like unit test 2, which backports new features from Python 3. But it can be an issue to have dependency, because 10 years ago it was a little bit difficult to install all dependency and take care of that. It was more difficult to install it. So we had to wait up to Python 3.2. You had the U issue, and you have to wait for the next release to get a fix for that. So after autumn comes the cold winter time. And we will start with our website called the Python 3 Wall of Shame. So in 2011, someone decided to create a website called Python 3 Wall of Shame. But the idea was not to blame the author of the modules. The intent was to motivate package maintainer to port their code to Python 3. But when the website has been created, only 9% of the top 200 modules were compatible with Python 3. And to recall what was Python 10 years ago, I identified 3 big players in the Python community. There is a Twisted, which is a very good networking solution for clients on server to do asynchronous programming, which is a very efficient way to do networking in Python. There is Mercurial, which is similar to Git. It's a source control management. And there is also Django, the very famous framework to do websites. And these 3 projects had different issues with Python 3. Twisted and Mercurial are very close to the hardware, to the low level. For example, Twisted works on the socket level, and at the socket level, the network level, there is nothing called Unicode, there are only bytes. So all the project is designed to use bytes. And in Python 3, using bytes is not the first citizen class type. We prefer to use Unicode, so at the beginning it was a little bit difficult to Twisted to port their code base to Python 3. And it's the same issue for Mercurial, because they used bytes not only for the file name for very good reason, but also for the file content. For these 2 reasons, it was also difficult, and it's still difficult to Mercurial to be ported to Python 3. And for Django, when Python 3 has been released, the support of Unicode was only at the beginning. So because it was very difficult to port code, because nobody wanted to be the first one to port code, we started to see this Frenchman who is a Python troll. And the Python troll considered that Python 3 doesn't bring anything because, as I explained with the manager, when you port code to Python 3, you still have the same features. It doesn't bring anything. And when you move to Python 3, you are forced to use properly Unicode. And nobody wants to do that because it's very difficult for good reason. And it's much more simpler to use Python 2 with bytes because you don't have to worry about Unicode, people speaking a different language. Just pass text and it works. So Python 2 is a failure. So maybe what we can do is just continue the development of Python 2.7. So there is an idea from the trolls is that maybe we can just continue the development and create a new version called 2.8 to add new features from Python 3, but don't break the backward compatibility. And 4 years ago, there was still an article saying that we were still debating transitional Python 2.8, and they were concerned that Python 3 would never take off, and also that Python 3 only represents 2% of packages. To make things more explicit, we wrote a PEP called the PEP not found, the 404. It's a Python 2.8 unreleased schedule, so it's a very obvious, a very explicit document to say that we know that we are breaking the backward compatibility, but we are not going to spend more time on Python 2 because we are a small team of core developers. We don't have enough time to maintain 2 versions. And if you use the numbers differently, in 2013, someone else counted that there are 80% of the top 50 projects which were compatible with Python 3, so it wasn't that bad. And Python 2.7 as his end of life extended at the PyCon in 2014. And for me, it's one of the best moves that we did for Python 3, is that we say that, okay, we know that it's difficult to port your code. You have very good reason to not port your code today because not all dependencies are compatible, because it costs a lot of money, and we don't want to force people to move to Python 3. We didn't want to force people to do anything, so we just say that you have 5 more years to do your work, and we extended the deadline to 2020. So after the cold winter comes fresh air, flowers. It's a new beginning. And the first great move for Python is that our first problem has been solved. So what is our first problem? Is that when you wanted to install a dependency, which was a very common question because using dependency is a good practice. The question is, how can I install a dependency? And the answer was, oh, you have to install SeptoTools. Okay, but how can I install SeptoTools? And it was a little bit difficult because you had to find a script somewhere on the internet, download the script. You need a system administrator permission to be able to run the script. It does install something on your system. It's not from the system, it's from the internet, so you have to trust it. It was not the perfect solution. But in 2011, pip 1.0 has been released. And in 2014, we decided to include not pip itself, but ensure pip, which is a new module to install pip directly into Python. So in Python 2.7.9 and Python 3.4, there is no ensure pip to be installed to very easily install pip. In practice, even if you don't have the internet connection to the internet, you are still able to install pip using that. And thanks to this change, slowly pip became the de facto installer, and you don't have to answer how to install dependency. You just know that pip is the correct way to do that. And we also see a Linux distribution to include pip directly in the system. So today it's very easy to have dependencies. To port an application to Python 3, we saw that 2 to 3 was not the best approach. So what we saw is that maybe we should not remove Python 2 support, but say differently, like add Python 3 support. And this is a big change, because you don't lose your users, you only move to Python 3 step by step, and you don't have to port all your dependency, all your code base at once. You can start with a simple change and or a single file and do it incrementally. And we started to see new tools like Modernize. It's a tool to convert your code base without losing the Python 2 support. And let me tell you the story of Sixer, which is my own tool. So I'm working on OpenStack, and on OpenStack, if you send a pull request generated by Modernize, you get a giant pull request, and you are sure that in a few hours you will get a conflict, because OpenStack is moving very quickly, and all files are modified, so it's really difficult to get a pull request with no conflict for longer than 1 day, especially a very large pull request. So what I did is to write a new tool which only apply selected operation, like for example just add parentheses to the print statement. And by doing that you can generate much smaller pull requests. You get less conflicts, and it's much more easier to review also for the maintainer, because you see that the change only had parentheses, so it's a simple change and it's easy to approve. And thanks to this tool, I was able to port all unit tests of OpenStack to Python 3. And another good advantage of this method is that if you have CI to validate all your work, you can make sure that each change doesn't break the backward compatibility. It doesn't introduce regression. So you can apply changes one by one and make sure that everything is fine. If you have a larger code base, maybe you need to do it differently, because some companies have very large code base, like for example Instagram or Dropbox have at least 2 million lines of code. So what they need to do is that when you have a very large code base, what you can do is first to add new tests. Because sometimes in a big company, people like to add new features, but they just forget to add new tests. So adding a new test is a good practice for your existing code base, but it also helps to make sure that the migration doesn't break anything. And Dropbox is also trying to a different approach. They decided to work on the type annotation. The idea is that you annotate the type of the arguments of your function, but also the return type of your function. And by doing that, they expect that it will be much easier to port the application to Python 3 without introducing bugs. Because if you have a type annotation, you know which type are expected, and it's much more easier to make sure to validate everything. To make the migration simpler, we made different changes in Python itself, but also in tooling around Python. And the first big change is that in 2012, we decided to reintroduce the U prefix. Even if it doesn't make sense if you only look at the Python 3 language to have this U prefix, because all strings are Unicode by default. Adding the U prefix was very useful to write a single code base for Python 2 and Python 3. So it fixed a lot of issues to help people to import their code. In 2015, Python 3.7 has been released with a new operator for bytes. It's a way to format a byte string. This is very useful for projects like Twisted or Mercurial, which manipulates a lot of bytes. And we also added more Python 3000 warnings, so Python 3 warnings. We added these warnings in Python 2. So the idea is that even if you don't port anything, just enable the warning, and you will see which code may have some troubles on Python 3, and you have to first focus on this code before starting the big migration plan. And to be able to use Python free features, we saw more and more backports of Python free features to Python 2. For example, unit test 2, enum 3.4, which is a new enum module. And thanks to all these backports, moving to Python 3 really had something. And after the spring comes the summertime. So to come back to the website, The Wall of Shame, the author of the website decided to change the title from Wall of Shame to Wall of Superpower. And today we got almost 100% of the module which are compatible with Python 3. In practice, it's a little bit less. It's only 90% 5, because in this long list you have some modules which have been replaced by new modules because the old module doesn't make sense on Python 3, or the maintainer decided to restart from scratch. So in this list you have some modules which you can just ignore, and you can consider that the top 200 modules on PyPI are compatible with Python 3. And another good news for Python 3 is that finally, after a long development process, we had enough time to optimize Python 3, and Python 3 is now faster than Python 2. On this graphic, you can see the result of a few benchmarks, and the orange line is the normalized result of Python 2, so it's always 1. And if the other bar is lower, it means that Python 3 is faster. And you can see that depending on the benchmark, it's more or less faster, and in some cases it's way faster. To give you these numbers differently, there is a company, Instagram, which has 700 million users. So it's a very, very big Django application running every day on mobile platform, on everything. So it's a big project. It's fully written in Python. And they switched to Python 2 to Python 3. And thanks to this move to Python 3, they saved 12% of CPU just by doing the change. And they also saved 30% of memory, which is something very important for them, because when you have so many users, you need a lot of servers, and at this scale, the performance and it really matters. It's really expensive to have so much hardware. And if you didn't notice, Python 2 is a little bit old today, and even if we are doing our best to fix all bugs, sometimes we just cannot fix some issues, because the thing with Python 2 is that it's called super stable, because we have so many people which rely on Python 2. It means that if you do any kind of change in Python 2, even to fix a bug, there is a risk that someone rely on the current bug, and all the application rely on this bug. And so we think twice when we have to backport a fix to Python 2. And sometimes it's more a design issue that has to require a big change in the language. For example, the first bullet is Unicode. Even if technically we could try different options in Python 2 to have new warnings or new mode for Unicode, we decided to not touch the current implementation of Unicode, just because, as I said, a lot of people rely on it, and we cannot change anything because it would break too much code in the wild. Another example is that for security reason, we decided to randomize the order of items in a dictionary and in a set object in Python 3. Because if you inject a specific keys in a dictionary, you may get the worst complexity of the dictionary type, and in that case you may crash the server just by sending a few bytes to an HTTP server. So So what we did is to randomize the order, but we cannot do that in Python 2 because if you change the order of the dictionary, the representation of a dictionary change, and it can break too many unit tests. So for your information, you have to explicitly enable randomization using dash uppercase R to enable the workaround for the security issue. Another very annoying issue of Python 2 is that the subprocess module is not thread safe. So maybe you did not notice because you don't use threads, or maybe you did not notice because you're lucky. But the idea of not being thread safe means that everything is fine until one day in production you get a crash and nobody is able to reproduce a crash because it really depends on the workload, it really depends on the order of operation. On your developer laptop, you have different timings. So it's very common that race conditions only occur on production. So nobody wants to rely on something which is not thread safe. So be careful with the subprocess. And for your information, there is a backport called subprocess 232, which backports the thread safe implementation. Another example is a recursive lock, which again is not as a race condition, as the race conditions are not threads but signals. It means that if you use recursive lock and you get a signal, signal is, for example, that you spawn a process, and when the child process completes, you get a notification to say that, hey, your child completed, it's time to read the status, the exit status of the process. So when you get the signal, you may get a race condition, and your lock may become inconsistent. So you may get a deadlock just because of a signal. And this is really annoying because a signal can come anytime. It really depends on the timing of the child process, and you don't control the timing of the child process. So it's really dangerous to use a recursive lock on Python 2. And another example is that the clocks in Python 2 use a system time. So during winter time or summertime, when you change your clock for DST, your application may crash just because of that. Or, for example, if the system administrator decided to change the time manually, again, you may get a crash. And the solution for that is to use something called monotonic clock. So monotonic clock only increase. There is no jump in the future or in the past. So the good news is that you just have to switch to Python 3 and you're fine. So for example, for the time in Python 3.3, I added the time.monotonic function, and slowly we modified Python to use monotonic clock inside Python. And to explain you something else about Python 3 is that, as I said, Python 2 is super stable, we cannot touch anything. And the good thing with Python 3 is that it's still kind of not as popular than Python 2, so we can afford to make more backward compatible changes. For example, I changed how file descriptors are inherited by child process. And since Python 3.4, when you spawn a child process, you don't inherit the file descriptor. It means that you don't inherit OpenSocket, you don't inherit the sensitive file which contain password or all your secrets. But this was our backward compatible changes, and we cannot do such change in Python 2. And another example is that in Python 3.5, I made another change, which is to when you get a signal, the syscall is interrupted, you get an error. And the behavior in Python 2 is that you get an exception and you have to do something. And in Python 3.5 is that if the signal handler doesn't raise an exception, Python will just retry the blocking syscall for you, and you don't notice anything. You're just fine. And Guido van Rossum, when he approved my change for the file descriptor inheritance, he wrote that We are aware that the code breakage this is likely to cause, and doing it anyway for the good of mankind. And again, Python 3 is much, much better because you have a lot of new modules in the standard library. I counted 21 modules for 3.7. And just to give you some examples, there is async.io for asynchronous programming. There is enum for enum, which is very useful. There is pathlib, which is very popular to manipulate paths. There is unittest.mock, which is a very, very nice way to reduce the dependency of a unit test on really test something very specific, so to mock another function. And not only we fixed bugs and we added new features, we also made changes in the language. And for example, in Python 3.6, we added something called the f-string. It's a new way to format string, and in my opinion, it's just the best way to format string because it's very short, it's very obvious when you read the string, and yeah, it's just the best because not only you can format a variable, but you can even call a method. You can, in practice, you can add any Python expression. It just works. It's amazing. And for asynchronous programming, we made different changes. First, we added the yield from. After that, we added async on await keywords. And we also added support for asynchronous generators, so yield inside an asynchronous method. There are asynchronous list comprehension. But you have also more changes, like for example, we have the keywords only arguments, which are very useful to write a better API. The print is no longer a statement, but it's a function, and I really prefer to have this function. You can use the star to unpack, but also to inside a list now you can use a star. This is a new feature. It's a new way to build a list, and in my opinion, it's straightforward and very useful. You can also do it for dictionary. You can use underscore inside numbers to make numbers easier to read. You can annotate the type of variable. For the with context manager with statements, you can add multiple expressions. There is again the bytes formatting. And there is something very useful for NumPy users. There is a new operator for matrix multiplication, which is @. It avoids to. This is an infix way for the matrix operation, because previously you had to call a function and it was harder to read. So I spent a lot of time to explain that Python 3 is way better. And we are reaching slowly the deadline, which is in 2020, the deadline of Python 3, the deadline of Python 2. So the question is now, is it time to maybe bury Python 2? So the good news is that in Fedora we already started to do that 3 years ago. In Fedora 2023, there is no Python 2 by default. There is only Python 3 by default, and in the release of Ubuntu last year, there is no Python 2 by default, only Python 3. And there is a Python 3 statement, which is a common timeline for all applications for the end of support for Python 2 in their application. And there are big projects like IPython 6 and Django 2, which dropped Python 2 support. And I'm working for Red Hat. So for your information, in the latest release of Red Hat 7.5, we announced that Python 2 is deprecated. So if your manager still have concern about Python 2, you can say that even Red Hat, which has a very, very long support, we are aware that something is wrong with Python 2, and we are working on that. And for your information, the next release of Red Hat Enterprise Linux will be Python 3 only. And This is thanks to my very cool colleagues who are working on that for 2 years. And if you use Red Hat Enterprise Linux or CentOS, there is also something called software collections, which is a way to install the latest version of Python on your old system. So technically, it's already possible to use Python 3 on Red Hat. And one open question for me is that we saw that changing the syntax and changing Python was really difficult. So maybe we can try to handle this issue differently and maybe try the JavaScript issue solution, which is to use transpiling using Babel and Polyfill. And by doing that, you are able to use the latest language on your old browser. And thanks to that, they are able to move way faster because you are no longer stuck by the version of JavaScript on your browser. You can use new features. Okay? Question?
Thank you so much. Thank you. We have time for a few questions, maybe. If there's... I've seen one over there.
Just to come back to the latest slide, to be honest, I think that we understood that Python 3 was a huge pain for everybody, and if we do that one more time, we will not afford to break everything. And my expectation is that Python 4 will just be the release after the previous Python 3 release, and we will follow the same deprecation process to have a slow process to give at least 2 releases to remove something. So we are not going to break Python one more time.
That's good to hear. I just was wondering whether the chart about performance was like generic case, because it puzzles me a bit. And the point is that from what I saw like around the internet, usually Python 2.7 performed faster on the general computing, but is there like an usage of async or something like that which drastically changes the chart, or it's like the general case?
I spent a lot of time to work on benchmark because I wanted to optimize Python. So this chart comes from a project called Performance. It's a benchmark suite. So I'm not sure that they are real representative of real applications, but we are trying to use more complex benchmark to have a better idea of what is a Python performance. And what I just can say that on this benchmark suite, Python 3 is always faster. There is only one case where Python 3 is slower, is a startup time, but we are working on that and it's getting better. So I'm sure that in some specific cases, Python 2 is still slower. But the good news is that this chart is for Python 2.6, it's an old chart, but Python 3.7 is even faster. So maybe you should try the latest version of Python. Because we optimized the method call and many other small changes.
Okay. One last question. Is there any? Huh? Okay.
So, knowing how the transition went, what would you do differently if you could do Python 3 again?
I tried to explain that 10 years ago, the choice that we made was the good way to do that. Because we didn't have enough information, that we didn't know that we had so much users, we are not aware of the big dependency chain. So yes, if I do that again, what I would do is just to have a very smooth transition to make sure that even if we break something, we have a lot of time to port the code and not to push all backward incompatible change at once, but do them one by one and make sure that we have the right tooling to do the conversion, right tooling to detect issues in your code. Because one of the very difficult issues of Python 3 is that when you divide two integers, you get a float. And this specific issue is really difficult to catch in your code because just by reading the code, you don't know the type. So we need more tooling to detect that and to help users.
Okay, thank you so much.